Namaste. Okay, today, guys, I wanted to introduce to you the concept of something called a vector. This is important. This is important because, or an important concept in physics, because physics, what it does is it describes the natural world. And we didn't just invent this. It seems that the natural world, the universe, actually has things called vector quantities in it. And I'll go on with that in a second. Here, let me just start the presentation. Okay. And all right, so what you got is a vector. I'm going to talk about two things: vectors and scalars. Okay, and what a vector is, it's a quantity. It's something that has a size, but it also has a direction to it. A scalar is something that only has a size. So you can see one of the bullets here that the concept of a force is what we call a vector quantity because force has a direction to it if you think about it. So force is in America we tend to use pounds of force as the unit of measurement of a force, and it makes a difference when you push on something with 100 pounds of force. It makes a difference in the outcome of the situation, which way you're pushing on it. So the direction is relevant. So it makes a difference whether you're pushing with 100 pounds on the object to the right or to the left, or if you're pushing up on it or down on it. All right. So force is a vector, as opposed to a quantity like a scalar. A scalar is just a quantity that's measured with just a number. So oftentimes the example we give as a scalar quantity is like the temperature in the room. Right now, I'm in my house. It's August, and it's the temperature in the room with the air conditioning on is about 70 3 degrees or something like that. So 73 is just a number. All right. So it wouldn't make sense, and that describes adequately the temperature in the room. It wouldn't make a lot of sense to say, okay, what's the temperature in the room? Well, it's 70 degrees at 37 degrees north of east. That wouldn't make any sense at all. But it does make sense to say something like, well, I'm pushing with 200 pounds of force at 37 degrees north of east. That does kind of make some sense. So force is a vector, temperature is a scalar. All right. Distance is a scalar. All right. Distance, like how far you go. All right. So 3 miles, that's a scalar quantity. All right. And that kind of makes some sense. Well, how far did you walk? Well, I walked 4 miles today. All right. Okay. That makes sense. All right. Now we'll get into this later. There's a vector analog to distance called displacement. And a displacement is a distance with a direction to it, which makes sense in navigation terms. All right. So if you say, for example, all right, okay, here I am at my house. All right, where is the school related to my house? Well, it's 5.3 miles at 45 degrees north of east from here. Okay, that makes some sense. All right, that's not kind of like a crazy thing, right? It gives you a distance and a direction at the same time. And if you follow that distance and direction, you would arrive from your house to the school if you were able to go straight. So the displacement is a vector quantity, whereas just distance or how far you go is a scalar quantity. All right. A vector is represented by an arrow. Okay. Okay. So here's pictures of vectors. All right. Here's a force vector right here. So here's a kid on a sled, and here's what it looks like mom or so is pulling the kid on the sled. So all right, so here she is pulling. She represents a force which is transmitted through the rope attached to the sled, and you notice this force is at an angle. Okay, so she's pulling at an angle. So what we could do is we could draw her force as an arrow in the at raised at the angle that she's inclined at. Okay, and the size of the arrow matters. The bigger the arrow, that means the more force there is. The smaller the arrow, the weaker the force. So you use the size of the arrow to represent how big of a quantity you're talking with and about, and then you use the angle to show the direction of it. Okay. All right. Um, Here's another example. All right. Here's a force being applied to a wrench. All right. We'll get into this a little bit more later. This force applied at an angle to something like a wrench, you get another quantity called a torque. But so anyway, but that's a different lesson. But here is a force vector. You probably caused by somebody's hand on the wrench. All right, but you don't draw the person's hand, you just draw the arrow representing the force that's on the wrench. Okay, so there you go. All right, here we go, distance versus displacement. I kind of already explained this. Distance is basically just how far you go, and your displacement is how far you go relative to a start point. So it has a direction to it. And I know that my camera thing is in the way there, so I'll just move it a little bit. So for example, an example of a distance would be 50 miles. An example of a displacement would be 50 miles due east. And you're probably saying, like, when would I ever use that? Well, normally if you're just driving in your car, you don't need that kind of information. You don't need the displacement. All right. You just kind of go by the distance. But if you're in a different type of vehicle, like, well, this is the ocean state. So when you're in a boat or something, oftentimes the displacement is quite relevant. If you're planning on taking your boat out to the tip of Montauk, for example, you're probably going to use displacements there. All right. So you're going to say, like, all right, okay, so I have to go 38 miles at, 83 degrees, north of east, or 38 miles at 7 degrees east of north, either of which is the same direction. That makes a little more sense. Aircraft also tend to use displacements for navigation. So cars, not so much, but other types of vehicles, they use displacements, and they're relevant. Okay. All right. Here's just an example. All right, these two diagrams or pictures show an example. So here's a start point and here's an end point. So this, let's say I walked it, from here and I ended up over here, but I took some random path and it went this way and then it went that way. So this, for example, would be a good example of who would take a path like this. Well, probably Mr. Kelly, as he's walking out of a bar, on a Friday night after he got kicked out or something like that, would get to, here's the bar, here's his home, and he just took some random stumbling path, and then he wound up at his home, hopefully, probably face down on the front lawn. But so this whole line here, this path represents the distance that the person traveled. The displacement is a vector. It just goes from where you start straight to where you end up. So the displacement is different, a little bit different than the distance. It's a vector. It only has 2 points that are relevant: the start point and the end point. Okay. Here's just another example. So here's a home. Looks like this dude on the bike needs to go to work at the factory. Okay, fine. The distance that he's traveling is 200 meters on the bike, because obviously there's some hills in the way. So he's not going straight through that with a bike. So he takes this 200-meter distance to get to the factory. His displacement, if you just start at the home and then end at the destination, the factory, is 120 meters. Okay, just straight that way. And that's kind of just the short of the concept between distance and displacement. One is a scalar, distance, and the other is a vector, displacement. Okay, you can add vectors. In this case, we're adding displacements. And the process is called tip to tail. Okay, so make sure you know this. When we're talking about vectors have 2 parts to them. Okay, the pointy part, which is where you end up, that's called the arrow part, the head, the tip of the arrow is called the tip of the vector, and then the back of the arrow is called the tail, kind of like an arrow. All right, so there you have it. So when you're adding two vectors, let's say here's a 40-meter displacement to a 30-meter displacement. Okay, you add them. The way you add them is tip to tail. So you take the tip of the first vector and you place the tail of the next vector by it, and then your answer. So what's your overall displacement goes from where you started to where you ended up. Okay, so here's a 40 meter, here's a 30 meter. The answer has a special name. It's called the resultant. Just learn the language on that. It's not hard. All right. So when I say resultant, it means what you get when you add several vectors. It's the answer that you get. The resultant in this case, if this is like a 3, well, this would be a 3, 4, a 5 right triangle. So the resultant would have to be 50 meters at whatever angle this is. Okay. Okay, so that's the gist of it. The other part of the lesson is make sure you get a crowbar. It's good to have in case of a zombie apocalypse and also during a pandemic outbreak. Good to have one of these things around the house. All right, so it's a good tool for opening things, and also if you need to kill a zombie, right, you can crush its skull with this end over here. That's a good thing to do. So make sure you have something like that. Okay. The questions to ruin your self-esteem and make you feel bad about yourself, I will just post on this. All right. So you can see them. All right. Make sure you can answer every single one of these. How is a vector different from a scalar? What's the difference between distance and displacement? What is the most practical non-projectile weapon to have in the case of a zombie apocalypse? That's going to be on the exam. So make sure you know that. All right. What type of quantity is a force? Why is force a vector? I explained that at the beginning. And if a person moves 3 paces to the right and 4 to the left, what is his distance and displacement? Actually, I'll just do that one right now. If you move 3 paces to the right and you just follow the cursor, 1, 2, 3. 4 paces to the left, 1, 2, 3, 4. You moved a distance of 7 paces. What's your displacement? Well, your displacement only depends on where you started and where you ended up. So your displacement would actually be -1, or 1 pace to the left would be your displacement on that. So, okay. All right. That's about it for this video. Let me get out of here. And there you go. That's your introduction to vectors and the concept of distance versus displacement. All right, so namaste, go us out, and enjoy your apocalypse.